Okay, so this standard is going to be a lot on, well, it's all on physical science. In the past, this has been traditionally the lower of the standards, and strand 1 is over matter. So this is the chemistry stuff. You should know all of this. So the standard states that students will investigate and describe matter in terms of its structure, composition, and conservation. And then just like in standard 1, we have A through whatever to show how you meet that standard. So the first one is recognizing bonding occurs when outer electrons are transferred or shared. So anytime you have a chemical bonding, or chemical bonding is just when, well, they have to do with the valence electrons. Valence electrons, and they can be either transferred or shared. Can form either a covalent or ionic bond. What's the difference between covalent and ionic bond? They're both to do with electrons. Ionic bond does have charges, and it's right. Covalent bond sharing electron, and ionic bond is the transfer of electrons to create those charges. Come on, create. To create cations and anions. That's what I'm trying to get here. Cations and anions, what's the difference? Yep, cations are positive, anions are negative. Okay, molecule. What's the difference between molecule and I'm going to add compound, because those two are the two that you know the difference between. Contain all covalent bonds. So a molecule contains all covalent bonds like sugar, water, oxygen gas, hydrogen gas. Those are all covalent bonding, and they are molecules. Compounds can be covalent or ionic. So it's any mixture of two or more elements. And it can be covalent or ionic. A lot of times you use those terms interchangeably when you're talking about compounds, but really you should just use molecules for covalently bonded compounds. So all molecules are compounds, but not all compounds are molecules. Just like when you talk about in geometry, all squares are rectangles, but not all rectangles are squares, right? Yeah, huh?
All squares are rectangles. The rectangle has four sides. The square, each side equals each other, so not all rectangles.
Yeah.
Kind of puzzled with that.
What are valence electrons? Outer shell electrons. Yep. Okay, 12.2.1b. Describe the energy transfer associated with phase changes. So we have our phases, solid, liquid, and gas. When we go from, well, which one has the most energy? Gases. They are moving faster, so they have the most energy. Solids are barely moving, so they are, the molecules and the atoms are barely moving. So when we go from gases to solids, when the phase change occurs from gas to solid, that is called, let's see, exothermic. Even though the substance is getting colder, but it's called exothermic because the atoms or the substance has to get rid of energy. The atoms have to slow down. They release energy to become the next phase. So it's exothermic. And from a gas to a solid? Water vapor. When you see frost on your window in the morning, that is water vapor in the air that turned into a solid right on your window. Frost. And it can be from gas to liquid and liquid to gas, or liquid to solid.
I was gonna say, is like when you see your breath, is that typically a gas or is that just the water droplets?
It'd be water droplets. Yeah. Right. Do you guys know what it's called when you change from a gas to a solid? It's called deposition. So we have some phase changes. We have freezing, melting, vaporization, all those, but then we have those two weird ones. Deposition is gas to solid. I'm going to put G to S. I don't have room. And then what's solid to gas? Yeah, sublimation. I might be. Yeah. So solid to gas is sublimation. Like dry ice. Good example of sublimation. Goes into the gas phase right away. Okay, to draw the phases, there's a couple different ways. We can draw a graph like this where the temp, as the temp increases, it gets to a certain point and then it's going to stay the same. And then it increases again and then it will stay the same. Do you remember seeing something like this? No. Here is the solid. The solid would continue to increase in temperature until it reaches right here, and this would be the melting point. So at this point, all the energy is going into melting that substance. And then it increases as a liquid. Now it's all liquid. It increases temperature until it gets to this point. The boiling point, it will all boil until it becomes all gas, and it would increase temperature there. So you have that kind of graph. And you also have what's called a phase diagram. Looks like this. It looks kind of like, and each, oh shoot, I don't think it goes quite. Each element kind of has its own, or each substance. So it looks kind of like that. And in this temperature pressure range, it would be a solid. Higher temperature. This I think is gas and liquid. There you go. So it looks something like that, where it shows where the phases are with the pressure and temperatures. Okay, the three normal states of matter in terms of energy. So which one has the most energy? Gas, we said. We already talked about that one. Particle arrangement, which has the most space between the molecules? Gas. Solids are packed tight, right? And gases have a lot more space in between. Particle motion, which one is moving the least? Solids. Gas is moving around a lot. And then which one has the strongest bond between the molecules, the strongest force of attraction between the molecules. Solid. And that's why they are in solid. They're attracting each other, holding each other in one spot. Okay. Recognize the number of chemical reactions involve the transfer of either electrons or hydrogen ions. So when you transfer hydrogen ions, those are acids and bases. Acids will donate a hydrogen ion, and bases will then accept that hydrogen ion. What about the pH? What can you tell me? Nope, opposite. So acids are less than 7 and bases are greater than 7. H+, hydrogen ion. Okay, and then oxidation reduction we have not talked about. I'll give you a little acronym to remember this by. LEO-GR. Has to do, oxidation and reduction are transferring electrons. So LEO stands for lose electrons, oxidate. Oxidated, and then if you gain electrons, reduced. So I like to remember reduction usually means you lower something, and if you look at overall charge on the atom, you're lowering the charge. Electrons are negatively charged, so they have to gain electrons to lower their charge. So it's reduced. When you lose electrons, you're becoming more positive, and you have that atom has been oxidated then. Okay, pH. We kind of talked about the acid and base pH, but to calculate pH, you use the negative log of the hydronium H+ concentration. Anytime you see brackets around something, that means concentration, molarity. I don't think we've talked about that yet. Have we in this class, molarity? I don't think so. But I don't think you'll have to actually do any calculation with that. But a pH scale is all based on log 10. Rate of reaction based on temperature. So if I want to increase the rate of reaction, what would I need to do to the temperature? Increase or decrease temperature? Increase. I want to increase the temperature to get it to react faster. The atoms are moving around faster then, easier for them to run into each other and cause a chemical reaction. What about particle size? I want to decrease the particle size. They move faster. They'd run into each other a little more. Surface area. I actually want to increase the surface area because you'd have more surface on that substance to have a chemical reaction occur. Example of that one, think about if you have a sugar cube versus granulated sugar. Dissolving is not a chemical reaction, but it's the same idea. Which one dissolves faster? Cube or granulated? Granulated. There's more surface area there for the water to come and grab a molecule of sugar. Or if you bought a tube of hamburger, that just sounds gross, a tube of hamburger, but you squeeze it onto the pan and you just leave it like that, compared to chopping it up, which one cooks faster? Chopped up because there's more surface area for the heat to get to. Okay. And then temperature, what is temperature really a measure of? What are you really measuring at the atomic level? Right, and kinetic energy, yep. You're really looking, you're measuring out the kinetic energy of that substance. Do we need to go over where and charge of the electron, proton, and neutron? I think you guys all should have that down. Okay. Okay, properties of atoms, ions, and isotopes. Ions, what are ions? They have a negative, they can have a negative or positive charge because they have differing number of electrons, right? I'm going to say to produce charge. Excuse me, like a cation or anion. Isotopes have differing numbers of what? No? If I change the number of protons, I don't have the same element anymore. Describing organization of periodic table of elements with respect to patterns and physical and chemical properties. So periodic law, that periodic table is arranged according to what? Not weight. There's a few spots. In general, it goes up by weight, but there's a few spots where it actually goes down. No? Not mass number. Atomic number. Number of protons. Atomic number is the number of protons, so it increases in atomic number. But each of the atoms can have its own ion, so it can have differing numbers of electrons. Periodic trends. I would say the biggest one is that groups have similar chemical properties. And mainly because they have the same number of valence electrons, it makes them behave the same way. As you go down a group, usually they get more reactive. I should take that back. In group 1 and 2, they get more reactive because they're able to get rid of those electrons easier. Whereas when the negative ions, halogens, fluorine is the most reactive because it grabs onto electrons a lot easier. And those are electronegativities and electron affinities. We skipped that that part. We did talk about electronegativities, and that was how well they attract electrons. And we said fluorine had the strongest attraction. As you go across from left to right the periodic table, you get higher electronegativities, and as you go down the periodic table, you get lower electronegativities. So those are just some. There's several other trends, but those are the ones having similar chemical properties is probably the most important. Where are the groups, or what are groups? Vertical. And periods are horizontal. Okay, force and motion is strand 2. This will be stuff you learned in physical science, the physics part of physical science. So describe motion with respect to displacement and acceleration. Acceleration is a change in velocity over a time period. And displacement, it affects velocity. Velocity is the change in displacement over time. We have distance time and velocity time graphs. So if we look at, let's say this is my distance time graph. So I have distance versus time. And then here, there's velocity versus time. So if my distance versus time graph looks like this, what can you tell me? you're increasing the distance, which one has distance in it? Velocity. So it has a constant velocity because the slope is constant. And if you took rise over run, you'd have distance over time. That's the velocity. So we have a constant velocity. So our v over t, which is our acceleration graph, our velocity stays the same over the same time period, so there would be no acceleration. So these two graphs would be graphing the same motion, just different variables. Okay, what about, let's try a different scenario. Let's say instead of it looking like that, it looks like this. Now what? Is distance changing? No, it stays the same. So is it moving? Yeah. No velocity. Not moving. So our acceleration would be 0. Our velocity is 0 over the whole time, so it's right along the axis, so there'd be no acceleration either. Oops. Okay, and last one, we'll go backwards. I'll draw a velocity time graph, and then we'll draw in what the distance time graph would look like. So let's say the velocity time graph looks like this. So the velocity is constantly changing at a constant rate, so we have a constant acceleration. So this graph would look something like this, be a parabola, because it's accelerating. The velocity each time period is a little bit more. Questions over those? Okay, Newton's first law, sometimes called the law of inertia because it's the resistance an object has to a change in motion. So like a bowling ball and a ping pong ball, which one would have more inertia? The bowling ball. It's going to resist the change more than the ping pong ball. Okay, make predictions based on relationships among net force, mass, and acceleration. Newton's second law, F equals ma. So force is directly related to acceleration. Acceleration is indirectly related to mass. Vector versus scalar. What's the difference? Vector has magnitude and direction. How many guys are in trig right now? They said you just had a test over, right? So example, vector would be a velocity, but a scalar value would be speed. Again, you probably use those terms interchangeably, but velocity, really you need a direction with it. So it could be 60 miles per hour north, whereas the scalar value would be just 60 miles per hour. When you draw them, you usually use arrows and all that good stuff. Next is Newton's third law, and it says that all forces occur in equal and opposite pairs. And the next one is also a real world example. So your book sitting on your desk, your book is having a force down. The table, your desk has a force up on the book. So all forces have an equal opposite pair. And then last, I think this is the last one for 2. Then we have 3. Newton's law of universal gravitation and inverse square law. It's talking about there's gravity, there's a force of gravitation between everything. So even Sarah and Katie, there's a force between the two. But you just cannot feel it, or you don't, it's because the force from the Earth is so large that you can't feel it. It's negligible. But when we talk about planets going around the sun, we have the inverse square law relates the force of gravity to the radius, and it's proportional to 1 over r squared. So as the radius goes up, the force of gravity goes down, and it's actually squared. So if the radius doubles, the distance from the sun doubles, using the same mass, same object, the force of gravity would go down by 4. Okay, so that's what the inverse square law is. We'll probably take channel 1. Wait, we have time. We still have some time. Let's use it. Recognize that an attractive or repulsive electric force exists between two charged particles. This one should be fairly self-explanatory. I mean, you should know, based on your experience, the attraction and repulsion force. If we have two charged particles and they're both positive, would they attract or repulse? Repulse. When you have two differing charges and you have them far apart, is the strength going to be very much? No. I would, for you guys, go through those questions at the end. For sure, we will talk through channel 1. We will probably watch it and we'll review over this one. But you need to go over it, okay? It's a lot of stuff that we've already talked about in your questions, okay?